All right, let's go ahead and get started. Thanks everyone for joining. Today we're going to be talking about building your information architecture. So it'll contain a bunch of information around what is an information architecture, how does that relate to our engineering ecosystem, and some tips and tricks and just generally how to think about going forward with building your information architecture. A little bit about me. My name is Ganesh. I'm one of the co-founders and CTO at Cortex. Before Cortex, I worked at a fintech company for a couple of years, and I got to see the monolith to microservice journey. So from service number one to 100 plus services by the time I left, and saw a lot of challenges around just centralizing information about our entire engineering ecosystem, whether it was service ownership or runbooks or dashboards or lifecycle, criticality, just so much information about those services that we kept ballooning over time, and just saw the challenges in collecting and gathering all the information into a single place, and then using that to drive behavior and cultural change across the organization. And so problem got bad enough that I decided to leave and start Cortex about 4 years ago. And so excited to share what we've learned, both through my personal experiences, as well as just working with many customers over the last couple of years here. A little bit about Cortex. We're the ones hosting the webinar today. Cortex is an internal developer portal, and we'll talk a little bit about what that actually means. It is basically a whole bunch of different features brought into one. It starts with a set of catalogs. So catalogs are ways to track all the information about your engineering ecosystem, and it's fed by more than 40 integrations that come out of the box. Cortex provides a scorecarding tool that lets you drive standards and align the organization on outcomes and kind of get towards those outcomes as an entire organization. We help you not just define those standards, but make sure that new services and projects are meeting those standards from day one through project generation and scaffolding. And finally, we take all this information to generate prioritized actions for every single developer to really take all this information and make it actionable and personalized to help you drive those kinds of initiatives across the organization. Now, why are we hosting this webinar? It's because the first step of building your IDP is your information architecture. It is the very first step that's important in understanding, hey, what information are we going to track in our developer portal? How do we structure it? How do we model it? And we've helped a lot of customers do that. We've learned a lot of things along the way, both pitfalls of what not to do and things that have worked really well. And so we wanted to take all that information and share with everyone so you can kind of think about, how do I even start building my information architecture? What does that mean? And obviously we'll talk about how Cortex can help as well. A little bit about the agenda. So this is actually a two-part webinar. So part one will be around how to start thinking about and questioning your information architecture. And then there'll be a part two on August 10th, which is like the office hours and Q&A. So you can go back after this webinar, ask yourself all the questions we'll talk about today, and then come back on August 10th for that webinar, the office hours, and provide some more hand-on guidance about your information architecture. So extremely excited for that. And so a little bit of context, this webinar is not going to be focused on Cortex. It's general information architecture. How do you think about it? How do you question it? Because you might be actually thinking about an internal developer portal. You might be running an initiative to drive security or AWS end of life, and you're trying to collect a lot of information. Maybe you're just trying to coalesce information to drive efficiencies and tame the chaos of your microservice world. Maybe things have just gotten out of hand for a very long time, and you're trying to wrangle it all back together. And so this webinar is going to be very much focused on the concept of information architecture and how to think about an engineering ecosystem. So it will not be very Cortex focused at all. So hopefully everyone here can get a lot of value out of it as well. And so I've been mentioning information architecture a lot, but let's make sure that we're aligned on what that actually means. So what is an information architecture? At the end of the day, it's basically the practice of organizing and relating different things in your ecosystem to make it easy to find information, action on it, and make that very quick, reliable, and consistent. And so as an example from the engineering side of things, everyone here probably has some context on what your information architecture is, right? You probably have services and libraries and APIs and tagging schemes and ownership and how those things relate to your production environment and your staging environment and the actual code that it's touching, all the way to deployment events and CI/CD pipelines. And every single one of these things is connected to each other in different ways. And we all have like a mental map of what this looks like as an engineering organization. But today is all about how do we take that, how do we systemize that and make it more consistent so that anybody who's looking for information can do so very easily. We're not asking people like, hey, do you know where this thing is deployed? Do you know what tier the service is? Do you know what it touches? Like there's easy ways of answering all these questions, and everybody in the organization is speaking the same language, therefore driving velocity and productivity throughout the organization. So today we'll be very much focused on how do we take that out of our heads and put it on paper, put it into a system, and think about it in a more structured way. And why does this matter? Like, why are we even here? Why are we talking about information architecture? What we found is that without a strong information architecture, it really, really hurts developers. We did a survey of 50 individual contributor software developers and trying to understand, what are their main challenges? How do they think about information architecture? How do they work with internal developer portals? And what we found is that the vast majority of developers find it very difficult to gather information you need. It's impossible to find when you need it the most. They don't know what's available, even if the information exists. They don't know how things connect to each other, or when things go wrong, how do I act on this? And I think anecdotally, I'm sure everyone here has experienced that, right? It's like you're paged at 2 a.m. for some service that goes down, and there's a scramble in that first 15 minutes to just collect information. Like, what services is this alert even for? What is this thing named? I know in my last organization, things were named after Game of Thrones characters. And so we get alert for something and you have no idea what that information is. And I think what we found is that this issue is pervasive. Every developer is facing this without a doubt. But it's also not very easy to drive an information architecture. And so when we think about the broader ecosystem of how people are trying to define the information architectures, the majority of the time it's going through an internal developer portal. The developer portal is kind of like your single pane of glass, your system of record, your source of truth, whatever you want to call it, to coalesce and collect all this information, right? And when we think about, okay, how are people doing with internal developer portals? Most people are saying that the thing that made it the most difficult to deploy an IDP was the lack of alignment on an information architecture. We talked to so many customers that have spent a year thinking about taxonomy and definitions and what their data models are and how things connect to each other. And the reason for that is because you have to be very structured about how you think about your information architecture. It is a difficult problem for sure, but it is a lot easier when you start thinking about, hey, how do we speak the same language? What are the right primitives we should be thinking about? And we'll talk a little bit about that today. How can we make this easier? And how can we help you accelerate the process of defining information architecture and then adopting your developer portal if that's what you're looking to do? And one of the big things that we've learned over the past couple of years, helping people with developer portals, is there's so many things developer portals do, but all of it is a moot point unless you start with the right foundations. And what we've done is we've kind of taken the journey, the engineering maturity journey, and broken it down into multiple phases. At the very end of this is culture change, right? When you're thinking about your information architecture, when you're thinking about documentation, your developer portal, why do you care about any of this stuff? The reason you care about this, the reason anybody is here today for this webinar, the reason we're trying to solve this problem is to help engineering organizations change their culture to a culture of continuous improvement, where a culture of reliability, a culture of ownership, where it's part of your culture to care about these kinds of things, and efficiency is baked into that culture. And that's what we're trying to accomplish with this information architecture, with the developer portal. But how do you get there? We can't just jump straight into self-service or bootstrapping. Like, there is a systematic way to get there, and it starts with aggregation. It starts with collecting all of your service information, your resource information, all the information about your ecosystem into one place. And if you're wondering, oh, that sounds like an information architecture, that's exactly what it is. That's phase one of achieving a successful developer portal adoption, of achieving culture change. Because how are you going to go and change your culture and improve things unless you know exactly what's in your ecosystem? And then you can assess that quality. So based on the information you now collected, you can do amazing things with it. You can start assessing your ecosystem and say, hey, we're trying to accomplish X, Y, and Z. This is the definition of good. Where are we today? We can interrogate our information architecture and use it to answer these questions that we have about our ecosystem. Then based on that information, we can then start prescribing actions. We can tell people what to improve. We can start enabling developers to go out and actually act on those things and take the actions that we want them to do. And finally, we can start optimizing our engineering workflows. A lot of organizations may think about, hey, how do we optimize our processes? But you can't optimize your processes unless you started with collecting information and use that to answer a set of questions and driven new behaviors, and then figure out where your bottlenecks are. And as you go through this process, you start achieving that feedback loop, the flywheel effect of culture change. And this is why the information architecture is so important, because you really can't do anything without being able to answer questions about your ecosystem in a very detailed and systematic way. That all being said, let's jump into information architecture. There are kind of 3 core steps to modeling your information architecture. The most important here is know why you're doing it, right? We can't just dump into saying like, oh, we need to document everything. We need to, figure out our information architecture. There's a reason why you're trying to accomplish that, whether it's incident management, whether it's ownership and accountability. There's some higher level business engineering reason why you're trying to build this information architecture in the first place. Once you've done that, then we need to start defining our core primitives. How are we going to build our data models? What is the core atomic unit that we're going to build around? Because once you do that, it makes the rest of your architecture much easier. And then once you have those 2 things, then you can start figuring out, hey, what type of questions do I want to answer? Let's say we're trying to do incident management and we define a core primitive. Now we can say, hey, these are the 10 things I want to be able to answer in any given moment about our engineering ecosystem. And having these kinds of questions or example questions will help you then define your information architecture in a better way. And so, for example, we're going to talk about aligning on your primary key strategy, talking about tagging, and these things will be extremely, extremely important. So step 1, why now? Why are we trying to accomplish an information architecture? Why is it a priority? Why are you spending engineering resources on this? What are you trying to solve for? So let's talk about that in a little bit more detail. So you really want to start with why am I building this information architecture? What is our key use case? Once you know what your use cases are, we need to understand, why is this a priority? Why are we spending engineering resources on building out this information architecture? What kind of value is going to bring to us? How are we going to measure the success of this information architecture? There needs to be some sort of success criteria as you're going into this initiative, because it's easy to get lost in the cycle of documentation and information architecture modeling, and it's a forever project unless you know exactly what you're trying to accomplish. And a very great example of this is incident management, right? Every one of us has faced these experiences, and we just talked about this, where there's an incident and you're trying to collect a lot of information about your service that just had an alert. Whether it's, hey, who's touched this thing last? Where is the service deployed? What were the recent deployments? What infrastructure does it touch? Who owns a service? Who's currently on call for that service? Is there on-call rotation? What are the environments? What are the SLOs? There's so many things that you need to know about your service when there's an alert, so that you can quickly triage that incident. Why is it a priority? Because reliability is super important this year for us. How are we going to measure it? MTTR. We want our incident resolution time to go down. And so now we're answering these questions. We have a very clear understanding, and the engineering organization is aligned on what exactly are we trying to solve with our information architecture, and how are we going to make sure that this succeeds? Because then you can work back and say, like, okay, what is our V0? What is our V1? What is the most important things we want to track? What are the things we want to fix? And so you need to make sure you have 1 to 3 key use cases, and make sure you know how you're going to measure success of this entire initiative. Next, defining your core primitive. And this is kind of a very high level question, and I definitely want to talk about this in more depth. And so we're going to talk about, what is a core primitive? Why does it matter? And what happens if you don't have one? And so when we talk about a core primitive, you can think of this as kind of the atomic unit of your data model. Like, what is the smallest thing that you want to track? And the answer to that can be so many different things, right? A lot of organizations will say, like, oh, everything is like the endpoint level. We care about tracking the endpoint, like that's our atomic unit. Or individual pods and Kubernetes is our atomic unit. But the one tip to thinking about your atomic unit is really based on how your engineering team is organized. What is the smallest level of thing that a team is accountable for from an operational standpoint? And what I mean by that is, a team is likely accountable for a service. And they're accountable for that service because they're accountable for every instance of that service. They're accountable for building it. They're accountable for being on call for it. They're accountable for making sure security issues are resolved with the service. They're accountable for all the running versions of that service. But that is kind of the lowest level of granularity that we can think about that the team owns. And so what we see is 99% of the time, you cannot go wrong with defining your service or your code base as your core primitive. Like that is the center of your data model. And many organizations, I think, tend to spin the wheel on this part of the exercise, where you try to go too deep. And what ends up happening is this is where you end up spinning cycles, because every different function has their own definition of what their core primitive is. For example, the ops team might think about the pods, the security team might think about endpoints, but really just think about what is a team accountable for that has built that service, and the likelihood is it is the service in and of itself. And so an example of this is being on call, right? Your team is usually on call for the service. You're not on call for a specific pod. You're not on call for a specific endpoint. You're on call for anything that happens to that service. And that's a great way of asking yourself this question of what is your core primitive? And when you take a step back and you think about this, it makes a lot of sense, because once you have your core primitive being the service, you can say the service is kind of the middle of your information architecture graph. You have versions of that service running in different environments. You have multiple environments. You have an on-call rotation. You have SLOs and monitors, but the core of it all is a service. That is your core primitive. And once you define what that is, you're going to start being able to really quickly see patterns on what things talk to that service, what things are associated with that service. But the biggest tip here is, unless you have a reason to, don't stray from using the service as your core primitive, and make sure that you're not spinning the wheels forever on this. Like, make a decision on the primitive that you're going to go with and start building an information architecture, because it's very easy to get stuck in this part of the IA process. Next up, listing the questions you want answered. This kind of goes back to, why are we doing this in the first place? We talked about, okay, our use case is incident management, and our core primitive is a service. So now we've answered those two questions. Now, given that, for incident management, in order to drive down MTTR, what questions will we want to answer about our services? As you can see now how those things are tying together. We have a use case, we have a primitive, and now we can use that to drive what questions do we want to answer. So in the incident management example, we probably want to answer things like, who is accountable for the service? Who has last touched it? What criticality is it? What are the dependencies of the service? Where is it deployed? What's currently running? How is it connected to CI/CD? What are the SLOs and monitors? What is the on-call rotation for the service? What are recent incidents that have occurred for the service? These are all kinds of questions that I may want to answer about a service if I'm trying to solve for the incident management use case. And so we want to make sure that we're answering all these questions and basically thinking about, what is the surface area, right? What is the surface area of all the questions that we need to be answering, and really what metadata is useful to track? Because as you start listing questions, you'll start figuring out what data you want to be tracking, right? This is going to be extremely important, because you can think about this kind of like an agile process, right? When we think about product development, agile, we're talking about user stories. We're not talking about the individual, technical implementation. We're asking ourselves, what is the user trying to accomplish, right? Like, what is the user flow? As a user, I want to be able to do X, Y, and Z. Your information architecture is no different, right? Given the core primitive, given our use case, what do I want to answer about my services? What do I want to be able to answer about my core primitive? And so this starts to open up a lot of different questions around, hey, do we actually have a primary key that connects all this data together? Like, is there a tag or a label or something that connects things across our ecosystem? Is there a way to track ownership? What kind of information do we need? And the same thing can hold true for other use cases. Like, imagine your use cases are production readiness or security audits. For security audits, you maybe need to answer, hey, what is a change log? Who's accountable for making changes? Who's the manager that's accountable for a service? Where can I find all the vulnerabilities for that service? How is it connected to CI/CD? What are the recent scans? What are the scanning mechanisms? What is the PII surface area for this service? And so given that use case, there's a different set of questions now that we want to answer. And so you can see why having that use case in the primitive is so important to thinking about what information should we be capturing in our information architecture. So we've just talked about those 3 steps. And now, given that, I want to go through some tips and tricks that we have around your information architecture and how you can make it much, much easier for yourself as you're going down this process. Tip number 1, you want to align on your primary key. Why is it important? we've seen this be the thing that causes most organizations the largest number of struggles. What am I talking about? If you have an entity in your on-call, in your incident management, your CI/CD, your repository, there is mentally, as an engineer, we generally have like a mental model of that primary key. It's usually the name of the repo, right? It's like XYZ service, payment service, whatever like that unique identifier is, or the application, or whatever we want to call that. And ideally, that label is used everywhere. That label is used in your metrics. It's used in your CI/CD pipelines. It's used as your Kubernetes app labels. And that primary key will then connect all of your different systems together. But what we end up seeing happen is that most organizations are not using a primary key. Your Kubernetes deployments are named something totally different. Your CI/CD pipeline is named something different. The repo is named something funny because, as engineers, we love naming things. And so your repo is named something totally different. That makes it very hard to ask questions about your information architecture. And the overhead of connecting data and pieces in your architecture just becomes that much harder, right? For example, in incident management, in the incident management use case, a service might have many different things that it depends on. It might have batch jobs and cron jobs and Kubernetes deployments and SLOs and monitors and infrastructure that it talks to. And if there's no way to connect all those things together, and if you have to know kind of the esoteric naming conventions that you have, it's going to be very difficult during an incident to quickly look up that information. Whereas if you have a primary key, if you know that this is the name of the service everywhere, that's what we've aligned on, it's going to be so much easier to look up that information when you need it the most. And so really aligning on your primary key can save you a lot of effort in actually hitting your goals, but also in building an information architecture. Because one of the things you can start doing, and we'll talk about this later, is start automating your information architecture. You can use that primary key to automatically connect things across multiple systems. And it's easy because you're following convention over configuration. There's a convention that everyone's following, and you can start enforcing this across all of your systems as well. With that said, now that we know we're talking about what kind of questions you want to ask for, we want to make sure you have the right tagging strategy. This is probably a hot topic, and I'm sure everyone here at this webinar is thinking about this, whether it's for cost purposes, whether it's for ownership, but tagging is extremely, extremely important. When we talked about like being able to ask the kinds of questions you want to ask your data, it'll help you identify what kind of tags you need. For incident management, you probably want to make sure you have tagging in your traces. You probably want to tag infrastructure, environments, tiers, criticality. These are all kinds of tags that you want. So for example, you may have different set of standards for services versus libraries versus APIs versus batch jobs. Each of those things have different things associated with them. Like for example, let's take reliability. If our use case was reliability or incident management, then the questions we want to be able to ask are, hey, where is this thing deployed? Who's on call for this service? All the questions that we just talked about. But if you're not tagging your services and your core primitives correctly, you won't know how to enforce this information. For example, if I look up an arbitrary thing in our architecture, if I look up an arbitrary service, do I know what criticality it is? What kind of things should I be enforcing for that? Where is it deployed? Is this thing a service? Is this thing a library? Is this thing a batch job? Should it have SLOs? Should it have monitors? Like I don't know what to enforce unless I'm able to answer these kinds of questions about our core primitives. So really think deeply about your tagging strategy. So generally for your services or your components or modules, you want to tag them with things like the type of entity they are. Are they a service? Are they a library? You want to make sure that you're following a standard naming convention and a standard schema for your tags so that every team and every organization is not doing tagging differently. You want to standardize on that. You want to be tagging criticality and tier so you know how important that service is. You want to be able to automatically associate things across different parts of your ecosystem. So make sure you have the right tagging strategy because it'll make that just so much easier. And so obviously we talked a lot about information architecture and honestly how difficult it is and all the things you need to be thinking about for your information architecture. And so, if you're feeling like, oh my God, there's a lot here, I don't know where to start, I don't know, how I'm going to accomplish this information architecture, it really comes down to breaking it up into steps, right? If you don't have a primary key, that's okay. Most organizations don't have a primary key, but start defining those associations, start defining and connecting and building a database of what those connections are. Like, hey, given the service, I can quickly look up every single association in our ecosystem. Given a service, I know exactly which on-call rotation is associated with this. Given a service, I know exactly which Kubernetes deployments are associated with this, or what tags I should be looking up, or which namespaces I should be looking at. So yes, you may not have a primary key, but you can start standardizing and collecting this information so that you can kind of provide the same experience if you were to have the same primary key. So it's okay, it doesn't have to start that way. If you don't have a unified tagging strategy, it's okay. Most organizations don't, but you can use your internal developer portal initiative as a forcing function to align across teams. You can use scorecards to enforce that. You can use that to build associations across different systems. You can start building automation on top of the data that you're starting to collect. And so you can use this IDP as a way to drive that tagging that you're looking for. And it doesn't have to be an all or nothing thing, right? You can start with certain set of tags that are going to be the most useful for those questions you're trying to answer. So start thinking about what are the most important things that we need to be tagging with. And let's say you're like, we love tagging, we love primary keys, we want to do it, but we have 500 services already in production. There's no way we're going to be able to go back and update everything. Like it's too much. That's okay. Really think about how can we do this going forward, right? Every new system you're building, every new service you're building, how do we make sure that those new services are following new standards? Because if you start building things the right way going forward, people start to see the value, right? Developers start to understand, hey, this standardization, this tagging is making my life a lot easier as I'm asking these questions about our information architecture. And so they'll start to naturally go back and fix things in the rest of the ecosystem. And it gives you some proof points. Like, hey, what is the value of having all this stuff? Like, what is the value of all this work we're doing? And it's just going to be a lot easier because you can start including this information in your scaffolders, in your boilerplate, in the tooling, in the self-serve. Just make sure everything new, everything from here on out is following these standards. Everything is following those primary keys and those tags, because your surface area is going to only keep growing, right? You're only going to have new services. You're only going to have new libraries people are building. So the sooner you can start standardizing these things for new services, even if you're off, even if you're not 100% there, it'll make your life a lot easier, and it'll make the information architecture initiative just go much, much smoother as you think about the future state. Now, that all being said, I want to talk a little bit about why this stuff is relevant to us and how can Cortex help with some of this information architecture. At its core, Cortex is the engineering system of record, right? It is a way to track your information architecture in a single place as a system of record and use that information in so many different use cases, whether it's for your service and resource catalog as a single source of truth for everything about your services and your infrastructure, and then using that for programmatic use cases for incident management, whether it's scoring and prioritizing action items, enforcing standards like tagging and associations and SLO adoption and things like that, or whether it's scaffolding, like making sure that new projects are following those standards. Cortex is a system of record that can enable a lot of these things, and Cortex provides some of those primitives out of the box. And so whether it's the service primitive or the team of ownership, domains and product areas, resources and infrastructure, Cortex provides these data models out of the box within the system of record. And this system of record could then connect to all of your tools in your ecosystem. Cortex can talk to things like your custom tools, your identity providers, your APM tools, really helping you coalesce all the information in your entire ecosystem into a single place as that single source of truth for information in your information architecture. So I'm not going to bore you to death with the information about Cortex, but I'll quickly talk through how we can solve some of these things. To start with, Cortex will connect you with your entire engineering ecosystem, right? We have more than 40 integrations out of the box. So we can talk to your on-call providers, your cloud providers, your APM providers. And so we can connect all the information in your ecosystem back into the system of record so that you're building that information architecture, not just with the internal data, but the representations of your services in your broader ecosystem, right? It's like, how do we connect our entire engineering stack all together into that core service primitive that we just talked about? Cortex actually has built-in features around projects and primary keys. If you're following that convention over configuration, we can automatically associate things with dependencies, with infrastructure. We can use tags to connect services with the infrastructure that they use. We can connect with your Kubernetes just based on that primary key. But we also support you defining your own primary keys. If you have multiple associations, you can do that as well. But Cortex can help you auto-associate things and automatically connect those things in your ecosystem just making it so much easier to then auto-associate and build that information architecture. And if you're not doing that, like we talked about, how do you do this going forward? We also have a scaffolder that can help you make sure that all new projects are following those standards from day one. You're following those naming conventions. You're building that primary key into your new systems. The scaffolder is a great way of bootstrapping new services with the one click and giving developers a self-serve way of doing that and making sure that they're following all those best practices from day one. And for your old services or the things you've already built, you can use scorecards to automatically define, enforce, and track best practices and standards, whether that's tagging or production readiness or security audits. Cortex can kind of help you drive these information architecture principles in a more automated way. And the last thing I want to talk about is the data model, right? Cortex has already built in a lot of these data models out of the box. And so the way we think about it is Cortex provides a very flexible data model. So if you need to model your own things, you can totally do that. But in Cortex, we provide some opinionated sane defaults. They're like, hey, we really believe that your service is your core primitive, because that's what we see in 99% of our customers and the people we talk to. The service is the core primitive. So we start there. We think about teams and ownership and resources. All the things we see across our customer base, we've modeled in a very opinionated way. So you can start with those opinions or you can start from scratch. But we want to make it easier for you to represent that data model. So these things are built in and you get a lot of value out of that. For example, if you have a service in Cortex from a repo, we can automatically associate it with your Kubernetes clusters and figure out exactly which deployments are connected to that service. And then we can query that and say, hey, which one of our Kubernetes deployments do not have labels associated with them? Because that might restrict us in doing cost analysis. And so being able to connect this and having a very opinionated data model makes things more automated. It makes it easier to look up information. And it makes it easier for you to accomplish that goal of having an information architecture. And so don't reinvent the wheel. Cortex provides a lot of this stuff out of the box. And last but not least here, to wrap up the webinar here, I want to say this is hard, right? Building an information architecture, we all know this. Every single developer forever has talked about documentation and information and sources of truth and single sources of truth. Like we breathe this stuff day in and day out. And so we know it's hard. It's a very hard problem to solve. And every one of our customers, everyone we talk to knows that as well. And it's really about, hey, you don't have to start from scratch, right? You've already done a lot of work probably. You've started doing tagging. You've started doing primary keys. The idea is don't rip out all that work. Instead, just build that, systemize it, and represent that in your developer portal as the model it is today. And so you don't have to start from scratch. This doesn't have to be, hey, rip everything out and we're like doing this thing all over again, because it is a very hard problem. But the most important thing I want to highlight is this work will pay off, right? If you have a solid information architecture, you will have a competitive advantage in the market. You'll be able to move faster. You'll be able to provide a better developer experience. You'll be able to drive down toil, KTLO. You'll be able to improve MTTR. Like all the things we care about engineering as an engineering organization, you'll be able to drive better with an information architecture because you now have a single source of truth. And as we talked about, you can look up information consistently, quickly, and reliably. And so that information architecture is going to drive so many advantages across the organization that the ROI of this hard work is extremely clear. And so we highly recommend people to really think about, how do I model this? What value can we get out of the information architecture? And really think about internal developer portals. Think about your system of record. How am I going to track this stuff? Whether it's spreadsheets or database or a true system of record like Cortex, think about how you're going to track this and take advantage of the tools that are available to you and to drive that developer experience. And so with that said, I want to highlight that, again, we have an office hours next month where I'll be answering more tactical questions about information architecture. So based on what you've seen today, if you have questions around, hey, how should we be thinking about primary key? How should we be migrating our existing stuff? How do we think about a developer portal? How do we think about our system of record? Any questions you have, anything tactical, nothing too small, nothing too big, bring those to our office hours in a month. And we're super excited to see you all there. And with that, thank you all so much for attending. I know we ended a little bit early, so I want to give everyone a little time back. Feel free to stick around if you have questions. We'll be taking more questions in a month at the office hours, but really appreciate you all for coming and attending this webinar. And I hope you learned something useful about information architecture here today. So thank you, everyone.